We're going to start by looking at a smaller example with a 3 by 3 grid, and we'll let X be a violation of the first two conditions. For example, if we put a black chip in the second row, first column, all chips in the second row must be black. If we put a white chip here at the bottom of the second column, all chips in the second column must also be white. So we're going to have a violation here in the corner and here in the center. Our strategy to solve this problem is we're going to do casework on the number of black chips in the first column. Let's take a look at our example in the 3 by 3 grid where the first column contains exactly 2 black chips. Without loss of generality, we'll put the 2 black chips in the first 2 rows. Our third cell in the first column can't be black, but it also can't be white since everything in this first column must be black. So we'll make this an empty cell that would be a violation. In order for this third cell to be a violation, then at least one of these 2 other cells in the same row must contain a white chip. Either one of them does or both of them do. If this second column contains a white chip, then we get a violation for the remaining cells that are in the same row as a black chip. If both of these columns contain white chips, then it will look like this. We can also complete this grid by putting black chips here in these first 2 rows, giving us a violation in the lower right corner. To count the number of ways of arranging our black and white chips in this case, we'll have 3 choose 2 for the number of ways of placing 2 black chips in the first column. For the remaining 2 columns, we must have at least one column that looks like this, with a white and 2 violations. And the rest of them can look like either 2 blacks and a violation, or another one that looks like a white with 2 violations. We can write this as 2 squared minus 1, or 3 different ways. Now let's continue with a 5 by 5 grid, and we'll do casework on the number of black chips in the first column. We'll start with 5 black chips in the first column. We can't put any white chips in the remaining 4 columns, so these remaining cells must all be black. They can't be violations because, again, we can't have any white chips in these remaining cells. So this results in just one arrangement. Let's put 4 black chips in the first column. Without loss of generality, we'll put them in the first 4 rows. This last cell has to be a violation. In order for it to be a violation, at least one of these 4 remaining columns must have a white chip. If our third column has a white chip, then everything else in this column must be a violation. We can have any number of white chips in these remaining columns, or we could have 4 black chips in these same rows as our first row, and then we'd have a violation down here. So counting the number of arrangements for our first column, that's 5 choose 4 ways of putting black chips in the first column. Each of the remaining columns can either look like this middle one or this one in the 5th column, and there's 4 remaining columns, so that's 2 to the 4th. But we have to have at least one look like this, so we subtract 1. This gives us 5 times 15 or 75 ways for this case. If we have 3 black chips in the first column, without loss of generality, we'll put them in the first 3 rows, which means we have to have violations in the last 2 rows. At least one of these remaining columns must have a white in the last 2 rows. Apart from that, we could have 3 blacks in these same rows, creating these 2 violations. So our calculation is 5 choose 3 for the first column, 2 to the 4th for each of our 4 remaining columns, but we have to have at least one of them with 2 whites in the same row that have a violation in the first column. This is 150 ways. If we have 2 black chips in the first column, that's going to be 5 choose 2 for that first column, and again 2 to the 4th minus 1 for the remaining 4 columns, and another 150 ways. And a similar calculation if we just have 1 black chip in the first column. We can't have 0 black chips in our first column. That would mean we'd have to have 3 violations in that column. In order to create a violation again, we need to have a column or a row with a black chip and then a row or a column with a white chip to create our violations. We can do the same casework for the number of white chips in the first column. The count is going to be the same, so we'll just multiply the previous number of arrangements by 2. So counting, we have 175, 150 times 2, and another 75, and we'll multiply by 2 for casework on the white chips. This gives us our answer, 902. If you'd like me to solve any other math contest problems, please leave them in the comments.